Hello students, welcome to this lecture 1 quadratic equations. In this lecture, we will discuss previous year questions 1 quadratic equations. Okay, so let's get started. In question number 1, here it said the root of the equation x square minus 3x minus 5 times 5 plus 3 is equal to 0, where m is a constant. Okay, so here basically we have to find the roots of this equation, okay, of this quadratic equation where m is a constant. Okay, so here we have given 4 options. So among these options, which options will correct, that we have to say here. Okay, so student, here let us solve this problem. We have given a quadratic equation x square minus 3x minus 5 minus m times m plus 3 is equal to 0. Okay, so this is given to us. This is our quadratic equation, and basically here we have to find the roots of this quadratic equation. Okay, so here basically we will we will splitting the middle term minus 3x, okay, as minus of m plus 3 times x plus m times x. Okay, so if we split the middle term minus 3x as minus m plus 3 times x plus mx, then we will get x square minus m plus 3x plus mx minus m times m plus 3 is equal to 0. Okay, so now from these two terms, this term and from these terms, okay, so here we can common out x, then we get x times x minus m plus 3, and from these two term, this term and from this term, here we can common out m, then we get plus m times x minus m plus 3 is equal to 0. Okay, so it implies to us x minus m plus 3 times x plus m, this is equal to 0. Okay, so here we get the product of two linear factors, and the linear factors are x minus m plus 3 and x plus m. Okay, and here the product of these two linear factors is equal to 0. So therefore we get either x minus m plus 3 is equal to 0 or x plus m, this is equal to 0. Okay, so when x minus m plus 3 this is equal to 0, then you will get the value of x is equal to m plus 3. Okay, and when x plus m this is equal to 0, then you will get the value of x is equal to minus m. Okay, so therefore x is equal to minus m comma m plus 3. Okay, so the roots are minus m and m plus 3. So the roots are minus m and m plus 3. Okay, so now let us move to question number 2, and let us see what actually wanted to say by this question. Okay, so first of all, analyze the question. What actually want to do for this question, that must be analyzed by you. Okay, so in your exam, in your board exam, basically there we have to first analyze the question. Okay, what actually want to say the question, you have to analyze that. Okay, so here it said to us, if 1 is a root of the equations ay square plus ay plus 3 is equal to 0. Okay, and y square plus y plus b is equal to 0. So 1 is a root of the equation this and this. Okay, so student, here we basically have to find the value of ab. Okay, so if 1 is a root of the equation this and this, then we know this this important point. If alpha is a root of the quadratic equation ax square plus bx plus c is equal to 0, then alpha satisfies that equation. Okay, that means A alpha square plus B alpha plus C is equal to 0. Okay, that means, and in other words, you can say alpha is a solution of ax square plus bx plus c is equal to 0. Okay, so in this problem here, basically it have given to us one is a root of the equations ay square plus ay plus 3 is equal to 0 and y square plus y plus b is equal to 0. Okay, so here we have given these two quadratic equations and we have given this information. One is a root of this equation. Okay, now we here see two unknowns are available here. Yeah, one is A and other is B, and here basically we have to find the product of these two unknowns. That is, we have to find the product A into B equals to what? Okay, so in option A it is given 3, in option B it is given -7/2, and in option C it is given 6, and in option D we have given -3. Okay, so here let us think how to process. Okay, so let us think how to process, how to find the value of A and the value of B. Okay, after finding the value of A and value of B, you can be able to find the product of A and B. Okay, so first task, your first task is find the values of A and B. Okay, so here we can use the concept of roots. That means if x is equal to alpha is a root of a quadratic equation x square plus bx plus c is equal to 0, then alpha satisfies the quadratic equation ax square plus bx plus c is equal to 0. Okay, so here one is a root of this equation and also this equation. Okay, so now let us see how to solve it. So it is given that 1 is a root of the equations ay square plus ay plus 3 is equal to 0 and y square plus y plus b is equal to 0. Okay, therefore y is equal to 1 will satisfy both the equations. This must be kept on your mind. Y is equal to 1. This is a root of this quadratic equations. Okay, so y is equal to 1 will satisfy both the equations. Therefore, a times 1 square plus a times 1 plus 3, this is equal to 0. Okay, and it implies a plus 3, this is equal to 0, and it implies 2a plus 3, this is equal to 0. And if we calculate if we calculate the value of a, then we will get the value of a is equal to -3/2. Okay, so the value of a is equal to -3/2. Okay, and now 1 is also a root of the equation y square plus y plus b is equal to 0. Okay, so now y equal to 1 will also satisfy the equation y square plus y plus b is equal to 0. So now if we substitute the value of y is equal to 1 in the second equation, then we get 1 square plus 1 plus b is equal to 0. Okay, and it implies 1 plus 1 plus b, this is equal to 0, and it implies b is equal to -2. Okay, so the value of b is equal to -2, and we've already get the value of a, that is equal to -3/2. Okay, so now if we take product of a and b, so we get ab, this is equal to -3/2 times -2. Okay, and this is equal to 3. So therefore the product of a b, this is equal to 3. Okay, so here in this problem option number A is correct answer. Okay, so the correct answer for this problem is option number A. Now let us move to question number 3. So in question number 3, it said to us a quadratic equation whose one root is 2 and the sum of whose roots is 0. Okay, so here a quadratic equation whose one root is given, that is 2, and sum of whose roots is 0. Okay, so basically here we have to find the equation of this quadratic equation. Okay, so here we basically have to find the quadratic equation whose one root is 2 and sum of whose roots is 0. Okay, so here you can use the concept of relations between zeros of a quadratic equation and its coefficients. Okay, so you know if alpha and beta are the zeros of the quadratic equations ax square plus bx plus c is equal to 0, then alpha plus beta, this is basically equal to minus of coefficient of x divided by coefficient of x square. Okay, so if we use this concept, then we can find other zero. Okay, so here we let the roots be 2 and beta, and here 2, this is a root of this quadratic equation, this is given to us. Okay, so 2 and beta be the roots of this quadratic equation. Now it is given also sum of its roots, this is equal to 0. Okay, so 2 plus beta, this is equal to 0. 2 plus beta, this is equal to 0, and from this we get the value of beta, this is equal to minus 2. Okay, so we know product of roots, this is equal to basically 2 times minus 2, that is equal to minus 4. Okay, and now if we find the equation of this equation of the quadratic equation whose roots are 2 and minus 2. Okay, so now here the quadratic equation will be x square minus 4. Here in this x square minus 4, this is equal to 0. So in this equation here you see the linear terms x is not involved, since sum of its roots is equal to 0. Okay, so sum of its roots is equal to 0, since that is why in this quadratic equations the linear terms does not involve. Okay, so therefore the quadratic equation, this is equal to x square minus 4 is equal to 0. Okay, so here if you match the options, then here you will get this answer in option D, that is x square minus 4 is equal to 0. Okay, so the correct answer is option number D. Okay, so option number D is here correct answer. Now let us move to question number 4. So in this question here it said which of the following is not a quadratic equation. Okay, so here we have given some equation. So basically in some equation there the quadratic term, that is the x square terms involved, but in some there does not involve the quadratic term. Okay, so here you can see in first one we have given this equation 2 times x minus 1 whole square, this is equal to 4x square minus 2x plus 1. So for showing is this a quadratic equation or not, here we have to first simplify this equation. Okay, so if we simplify this equation, then we'll get a simplified version of this equation, and that equation, if that equation is of the form x square plus bx plus c is equal to 0, then this equation basically is a quadratic equation. Okay, otherwise this is not a quadratic equation. Okay, so first check option number A. So in option number A, here we have given 2 times x minus 1 whole square, this is equal to 4x square minus 2x plus 1. Okay, so if we simplify this, then basically it will give to us 2 times x square minus 2x plus 1, this is equal to 4x square minus 2x plus 1. Okay, and it implies 2x square minus 4x plus 2, this is equal to 4x square minus 2x plus 1. Okay, and it implies 2x square plus 2x minus 1, this is equal to 0. Okay, so here you can easily see this equation is of the form ax square plus bx plus c is equal to 0. Okay, so this equation is a quadratic equation, but according to the question here we need that equation which is not a quadratic equation. Okay, so here according to the question this option is wrong. Okay, so option A is here wrong option. And now if we check option number B, so in option number B we have given 2x minus x square, this is equal to x square plus 5. Okay, so if we simplify this equation, then we will get basically 2x square minus 2x plus 5, this is equal to 0. Okay, so this equation 2x square minus 2x plus 5 is equal to 0 is a quadratic equation, since this equation is of the form ax square plus bx plus c is equal to 0. Okay, so according to the question here we need not a quadratic equations, so option B is also a wrong option. Okay, so now if we check option number C, so in option number C here we have given root 2 times x plus root 3 whole square plus x square, this is equal to 3x square minus 5x. Okay, so if we check option number C, here you can easily see here you can simplify this. So if we simplify this equation, this expression, so if we simplify, then actually here you can use a plus b whole square, this is equal to a square plus 2ab plus b square. Okay, so if we expand this square term, then you will get 2x square plus 3 plus 2 times root 6x plus x square, this is equal to 3x square minus 5x. Okay, and it implies 2 times root 6x plus 5x plus 3 is equal to 0. And here this equation is not of the form ax square plus bx plus c is equal to 0. Okay, so therefore the given equation in option C is not a quadratic equation. Okay, and according to the question here option C is correct answer. Okay, so this option is a correct answer. Okay, so the correct answer for this question is option number C. And if we check option number D, so here you can simplify this option number D as x to the power 4 plus 4 times x cube plus 4x square, this is equal to x to the power 4 plus 3 plus 4x cube. Okay, so here x to the power 4 and x to the power 4 cancel out, 4x cube cancel out, so basically you will get 4x square minus 3, this is equal to 0. Okay, so this equation is of the form ax square plus bx plus c is equal to 0. So therefore this equation x square plus 2x whole square, this is equal to x to the power 4 plus 3 plus 4x cube, this is not a this is a quadratic equation. Okay, so according to the question here we need not a quadratic equation, so option D is also a false option. Okay, so this is a false answer. So here the only correct answer is option number C. Okay, so now let us move to question number 5. So here in question number 5 we have to find the roots of the equation x square plus 3x minus 10 is equal to 0. Okay, so here we can find the roots of this equation by using first factorization method, and we can also use quadratic formula that is known as SATHEE-ENGG formula. Okay, so first here we will use factorization method. Okay, so if we use factorization method, then you can split the middle term 3x as 5x minus 2x. Okay, then you will get these two factors, the product of two factors x plus 5 into x minus 5, this is equal to 0, and it implies either x plus 5 is equal to 0 or x minus 2 is equal to 0. Okay, so here we get the values of x, basically minus 5 and 2. So the roots of these quadratic equations are minus 5 and 2. So here we can also use quadratic formula. So you know, well, if we have this quadratic equation ax square plus bx plus c, this is equal to 0. Okay, then the quadratic formula basically is x is equal to minus b plus minus root over b square minus 4ac divided by 2a. Okay, and if we compare this equation with this standard form of quadratic equation, then we will get the value of a, b and c. Okay, so here a is equal to 1, b is equal to 3 and c is equal to minus 10. Okay, so now x is equal to minus 3 plus minus root over 3 square minus 4 times 1 times minus 10 and divided by 2 times 1. Okay, and this is equal to minus 3 plus minus root over 9 plus 40 divided by 2, and this is equal to minus 3 plus minus 7 divided by 2. Okay, so therefore we get the values of x is equal to minus 5 and 2. Okay, so we can also use the quadratic formula for finding the roots of this quadratic equation. Okay, so the roots of this quadratic equations are minus 5 and 2. So here option is correct answer. Okay, so this is the correct answer. Now let us move to question number 6. So in question number 6, here we have to show that x equal to minus 3 is a solution of this quadratic equation. Okay, so how to show a value, a real number is a solution of a quadratic equation. So we know this this result, if x equal to alpha is a solution of ax square plus bx plus c, this is equal to 0. Okay, then x equal to alpha, this is a solution of this quadratic equation if alpha satisfies the quadratic equation ax square plus bx plus c equal to 0. Okay, so here x equal to minus 3 is a solution of this quadratic equations. Okay, that we have to show here. So here we can substitute the value of x equal to minus 3 directly, and we can check is the value of this quadratic polynomial x square plus x plus 9 is equal to 0 or not. Okay, so but here we will first factorize this thing. Okay, so here x square plus 6x plus 9 is equal to 0. So this is actually x square plus 2 times 3 times x plus 3 square, this is equal to 0, and this is actually the formula a square plus 2ab plus b square. Okay, and this is actually a plus b whole square. So in left hand side we get x plus 3 whole square, this is equal to 0. Okay, so it implies x is equal to minus 3 is the solution of this quadratic equation. Okay, so x equal to minus 3 is the solution of this quadratic equation x square plus 6x plus 9 is equal to 0. Okay, so we can also approach in another method. Okay, so we can directly substitute the value of x equal to minus 3 in the polynomial x square plus 6x plus 9. Okay, so if you substitute the value of x equal to minus 3, then we get equal to minus 3 whole square plus 6 times minus 3 plus 9, and this is equal to 9 minus 18 plus 9, this is equal to 18 minus 18, and this is equal to 0. Okay, so here x equal to minus 3 satisfies the quadratic equation x square plus 6x plus 9 is equal to 0. Okay, so therefore x equal to minus 3 is the solution of x square plus 6x plus 9 is equal to 0. Okay, now let us move to question number 7. So in question number 7, here we have to find the discriminant of the quadratic equation 3 times root 3 x square plus 10x plus root 3 is equal to 0. Okay, so here we have to find the discriminant of this quadratic equation. So before finding the discriminant of this quadratic equation, basically we have to first find the values of a, b, c. Okay, so where a, b, c are real numbers. So first you have to compare this equation with the standard equation of quadratic equation, that is ax square plus bx plus c is equal to 0. Okay, and after comparing this equation with the standard equation of quadratic equations, you will get the values of a, b, and c. Okay, then you basically have to find the value of b square minus 4ac. Okay, so here let us see how to solve it. So we have given this quadratic equations 3 times root 3x square plus 10x plus root 3 is equal to 0. Okay, so here discriminant for ax square plus bx plus c is equal to 0 will be b square minus 4ac. Okay, and if we compare this equation with this equation, then here basically a is equal to 3 root 3, b is equal to 10, and c is equal to root 3. Okay, so now if we put all the values of a, b, c in this expression, then for the given quadratic equations, the discriminant this is equal to 10 square minus 4 times 3 times root 3 times root 3, that is equal to 100 minus 36, and this is equal to 64. Okay, so for this given quadratic equation, the discriminant is 64. Okay, so for this quadratic equation, discriminant is 64 and this is positive. So you can also extend this problem. So you can also extend this problem by, here the sign is basically positive. Okay, so the nature of the roots of these quadratic equations are distinct real roots. Okay, so I stop here this lecture. So the remaining questions we'll discuss in our next lecture. So thank you very much to all of you.